Awesome. Hello, everyone. Today is August 2nd, 2021. This is a meeting of the SIG Network Policy subgroup of SIG Network. It is a CNCF certified meeting, so please be nice to everyone, and let's have a good meeting today. So going ahead and getting started, I will share my screen, and I'll try to just take some notes during this discussion. Well, actually, Yang's going to be sharing his screen for the presentation. So I'll just try to take notes during this discussion revolving around cluster network policy. For people who are just tuning in, this discussion started last week over a presentation Abhishek and Yang spearheaded and put together. And, we're just trying to agree on use cases as a group and then look at two different implementation paths. One kind of pushed forward by Sanjeev and one pushed forward by Yang and Abhishek. So that's where we're at. If you want to go ahead and share Yang, I will give you co-host permissions. And you should have co-host permissions, and feel free to present. I'll be taking notes along the way. Does anyone have any questions before we get going about today? Cool. Okay, you have the floor, Yang.
Oh, okay, thanks, Andrew. So essentially what I wanted to do first today is that as many of you are in the meeting last week, we have been presenting, those use cases for the cluster network policy, or I should say, typical traffic patterns that the cluster network policy are supposed to regulate. And we try to sort of condense them down to those bullet points, which is, strict deny, strict allow, and blah, blah, blah. But in the last Monday's meetings, I hear a lot of people find it, really confusing, namely between the third and the fourth item, which is strict deny but allow exception and strict deny but delegate. The term delegate sort of confuse a lot of people on what they actually mean and how 3 and 4 differ from 1 and 2. So we had a internal cluster network policy discussion on Thursday, and I think Sanjeev pointed out that a picture might help clear a little bit on the use cases, or at least the traffic patterns that we're depicting here. Otherwise, people can really get confused on what those things mean. So I've put together a quick picture over here to see if it clears everybody's mind on what those use cases are. So this is following network policy API repo. We have a couple of PRs on the network policy API repo. One of the use cases was tenant namespace isolation, and Sanjeev originally put up a good depiction of the namespace tenant namespace model there, and I've done a little bit of coloring and stuff, and which is trying to explain what the strict deny and allow and delegated, what is all those traffic that is going on. So essentially, we are looking at the more complex model of the cluster network policy, which is with the non-overridable denies already in place for the namespace boundaries. Oh, sorry, I should say tenant boundaries. So essentially, what this strict deny and strict allow mean, first of all, is that if we have no namespace or tenant boundary isolations, then the traffic becomes pretty easy, right? Because you would either want to strict deny on the specific traffic, which, as we listed here, is a pod carrying sensitive data from namespace named isolate me, right? Those are kind of very specific pods or namespaces or workloads that you wanted to just deny, or you have things you wanted to strictly allow. For example, the core DNS pods. Now, those are sort of non-overridable rules, which basically just means Kubernetes network policies should not be able to override those rules. But the tricky thing is, when strict deny and strict allow are together on some of the traffic patterns, which takes precedence, right? So this is a problem, very can be illustrated right here, right? So you have, two tenants. One tenant may have two namespaces, and one tenant may have one namespace, and some tenant may have, three namespaces, for example. Now, the first thing you wanted to do is a non-overridable deny, which means that in a lot of cases, the cluster admins may want those tenants to be strictly isolated with each other. So those non-overridable denies are depicted by the red border here on the namespaces, meaning that for tenant 1 and tenant 2, they cannot talk to each other, and this is a strict non-overridable deny. But as you can see, if you have this strict non-overridable deny around those tenant namespaces, then the kube system, kube DNS will also be denied if it's not sort of like allowed on purpose, right? And also, there's another use cases that's I think originally brought up by Sanjeev, is that if you have some public service, which is a service hosted by another tenant, and there might be cases where another tenant's pods may need to actually talk to those services. So this will be sort of like an exception to the non-overridable denies that we must need to sort of capture, so that those things are not strictly denied, and in some cases it will be allowed. So this is what we depicted here as three different kind of traffics. First is non-overridable deny, which is the red boundaries over namespaces. Now there are two different kinds of like holes or exceptions we wanted to provide to those non-overridable denies. And one is what we call the delegate exceptions. And this is depicted by the yellow lines here. Essentially what that means is that, this yellow lines are just exceptions to the denies we wanted to provide, but a cluster network policy is not explicitly allowing this traffic, meaning that the namespace owners can choose to open or close those traffics at their own discretions. So if a tenant 1 namespace owner comes in and he or she decided, okay, we don't actually want to use the service public on another namespace, and for security reasons, we actually want to deny this traffic. So the namespace admin would use a Kubernetes network policy to isolate those pods in their own namespaces so that this yellow traffic line becomes a deny. But on the other hand, if the namespace admin wanted actually to access this service public in another tenant, he or she can still use a Kubernetes network policy to do so by explicitly allowing this. So we are handing over, whether this traffic is should be allowed or not to the tenant namespaces owners. So this is one flavor of the exceptions to the strict denies. And the other flavor of the exceptions of the strict deny is what we depicted here in green lines, right? So in those kind of cases, in most cases, right, a cluster admin would always want their tenants to be able to communicate with DNS services, which is kube system, kube DNS. Now, the tenant namespaces may or may not want to actually talk to the kube DNS services, and that's totally fine. But for a cluster admin, more usually than not, they will sort of like have this strict allow rules, which is overriding the default deny all namespace or tenancy boundary that's allowing the traffic from kube system to the tenant 2 namespaces or the tenant 1 namespaces. So as you can see, the yellow and green lines are the two kinds of exceptions to the non-overridable denies. But those are two different kind of like use cases where a clustered mean sometimes may want strong allow stance for those exceptions, and sometimes don't. Is there? I guess I'll pause here and try to see if there is any questions on those regards.
I know this was pretty confused some people last meeting, so this makes sense to everybody now. This idea of delegate versus strong allow versus deny.
It's clear.
So can you pop back to slide 3, Yang?
Yeah, sure.
Great. So, I mean, for me, that helped. The diagram helped explain these use cases. I think the one thing that we still have open to question is number 5, right? So what if we have, I don't know if you were going to talk about that or wait, but.
So one way to describe this would sort of be to have a tree, right? You have, I mean, the inclusion trees, you have namespaces and you have pods. And a pod sort of hangs under the namespace, and we can even have a tenant. And then you can express it as, I mean, if you have a namespace rule, it goes between the namespaces. And then you can describe an algorithm that will, you can have the arcs of different types, sort of that just say in which order you interpret the arcs. Then you can have, like I say, you can have an absolute deny at namespace level, cannot be overridden. You can have a strict deny by delegate. So if you have a delegate further on, that will be found. You will have the default rule, and then you will have the if you have pods that wants to override it, or then you will see that.
Yeah, the problem being tenants are not a first-class citizen in Kubernetes. So it's a concept that we derived and try to solve a lot of use cases that people.
A tenant would point to a tenant will point to a number of namespaces.
Right.
It's all inclusion, and a namespace cannot be part of more than one tenant. So you can express it as labels, or you can draw it as a diagram. It's just groupings, right? But anyway.
Yeah.
So Per, yeah, we just thought that this diagram would perhaps be, it's a networking diagram. It shows flows. So the thought was that that's a little bit more clear.
Skip the tenant, then we can still just have the namespace and policy in order to better describe the algorithm. So if you have different type of arcs, and then you can have an algorithm that says if two pods can talk to each other. Sort of what is the algorithm? You check this, you check this, you check this. I think that's one of the parts that's been unclear. Sort of what is the algorithm, and how does it get applied?
Well,
you have it here.
Yeah. So, but yes, exactly.
Just do a graphical example that shows how the implementation works, right? So this is exactly what's used to implement the algorithm.
No. So here I would jump in here. So this quote unquote flowchart is for a specific implementation which assumes an empower model, which assumes the aggregation across policies and so on. So this is not the functional description of the requirements. Okay. Another way of so the diagram is one way. The diagram is still a simplification. There's actually a little bit more detail, but maybe we don't want to confuse that right now. If we are clear on the diagram, that's a good step forward. But the other way to look at it is, look at how requirements are expressed. Like, for example, it would be worded like, as a cluster admin, I want a tenant to be able to do this. As a cluster admin, I would block, so that functional, non-ambiguous description.
I agree with you. Sort of that's where you need to start. But in the end, you want to come up to an algorithm that you will want to be able to see. Does this algorithm capture all the requirements that you start with use cases 100%, and that you apply that to some model, right? And we need to build that model, and then you have the algorithm or algorithms that interpret these things, and then you need to see that your implementation matches back to your requirements.
Yeah, we agree.
Yeah. That's yeah.
So going back to going back to Andrew questions, right? So in terms of number 5, which is default disposition, and yeah, so this is also a point of confusion. I think we haven't really discussed on how or whether this one should be strictly a use case to be solved for the cluster network policy here, and we believe that this is a reasonable use case. But definitely we wanted to hear more about the community on the feedback on this. So the default disposition is kind of falls in where what happens when delegated traffic is not handled by the namespace owner. Now, what should we do in this case? If we look at this diagram, it's talking about those yellow traffic lines. Right. So let's just take the service public, for example. And this is I think this is a pretty clear traffic pattern here. So let's say if we have poked this hole through the non-overridable denies, and we left the namespace owners to decide whether this is should be allowed or denied. Now, what I just
should it be namespace owners? You said owner. Both sides need to agree, right, to get this to work, I hope.
Oh, right. Sorry, the tenant owner, I would say. So, sorry by the ambiguity, but the tenant owner, I would say, right? So essentially, we are deferring this to the tenant owner to decide whether this traffic should be allowed or denied. Now, there are 2 things that they can do. First of all, they can have a explicit allow rule, which is Kubernetes network policy, saying that I'm selecting this this pod behind the service, right? And I'm allowing the traffic to going to or from this service. And the other possibility is that it's the tenant owner basically isolates those pods further, saying that okay, I want those pods to maybe talk to each other, but I'm not listing this as allowed, right? So this kind of like rule, this kind of traffic just keeps hanging in there, right? Because if you think about policy evaluation or in whatever implementation model of the CMP, right? So what we wanted to do is that CMP will be evaluated first, and the CMP doesn't really capture whether this traffic should be allowed or not. Now, on the second layer, the tenant namespace owners also doesn't have a explicit network policy saying that whether this traffic should be allowed or not. So this traffic will still fall open to maybe whatever the default cluster traffic policy is, which in the native Kubernetes or the vanilla Kubernetes case will be always allowed. Now, our intention was to capture, if that's something that's happened, right? If the cluster network policy writers explicitly left this traffic out, but the namespace owner doesn't really act upon it or create any rules to capture, whether those should be allowed or denied. Should there be a default layer or default position layer of cluster network policy that dictates what's the next default disposition for this traffic? And by namespace owners or tenant namespace owner not acting upon those, we actually mean that there are actually no Kubernetes network policies. So for example, if the tenant 1 namespace owner have a Kubernetes network policy and says, I'm applying the network policy to all those pods, and I'm essentially isolating those pods, which says ingress and egress empty, all right, and essentially I'm now allowing any ingress or egress traffic. That's acting upon this traffic pattern because they're essentially saying that those pods are isolated and this should be denied. So not acting on those traffic is basically, when we left this traffic open and the tenant namespace owner actually don't have any Kubernetes network policies.
So what would be reasonable? I mean, I really like the tenant, but I mean, to me, a reasonable thing would be to say, oh, sort of by default deny traffic between tenants, but allow traffic between a tenant's namespaces. That would be sort of a default setting you probably want to have in some systems. But if we don't introduce sort of the tenant concept into the cluster network policies, it becomes very hard to set that up, because you need to do it explicitly for these groups of namespaces, which might change over time, right? So it's something that changes all sort of, you add and remove from the set, and you have no way really to describe it. Maybe you can with a label, but.
So Per, the assumption here is that, and maybe this again needs to be documented to some extent, but without being over prescriptive, is that there is an appropriate labeling scheme. There's an appropriate namespace labeling scheme which identifies the namespaces to tenant mapping.
Okay, but then we're good, because then you should be able to say, because implementation is one thing, right?
And that is under the control of the cluster admin.
At the expression level, you want to be able to say, and in a understandable way, right, that you set the policies so the tenants' namespaces cannot talk unless someone explicitly allow it on both sides, right?
Yeah. So
that a tenant can then restrict communication within his own namespaces if he wants.
Yeah. So another point here is that since we are not the multi-tenancy group, we are not being overly prescriptive on a exact multi-tenancy model. We want to allow the kinds of multi-tenancy models that seem reasonable without particularly fixing one exact tenancy model, right? So we are the networking policy group. We're not the multi-tenancy group. We just have to provide some tools that can allow 2 or 3 reasonable multi-tenancy.
I agree with you on that.
Yeah.
Sort of that. So, yeah. You still need to be able to reason about it to be able to see what makes sense, right? And
yes.
Then without locking down things too hard.
Yes. So, which is again why I think having an explicit diagram on what the tenants are, what are their allowed and disallowed communication paths, or what is the kind of flexibility that an admin should have, which this is just one example. We are not edicting.
But I think the conclusion you get, if you're just talking today about namespaces, it's very hard to do this unless you have the concept of a tenant. And how that is implemented, if that is labels or if it's a new object that you have relations to, doesn't really matter. The question is just that you have the expressibility and that you can use them then in a way that makes sense in the policy.
Yeah. Right. One other point is that I did check with a few other people, including solution architects and so on, who felt, so there's, in terms of data points, there are products like Rancher, which group X number of namespaces into a tenant. So there is precedent for this, right? Secondly, querying solution architects, the feedback was, yeah, this makes sense. If you have a labeling scheme for namespaces, that would be a reasonable way to implement a multi-tenancy solution. So we have had a little bit of feedback, both because of competitive products, as well as some feedback from solution architects.
When you say solution, that's for
that happened to be
going to bring some up, but that's for V2 discussion, so I'm not going to bring it up now.
So, but getting back to the meat of the question, right? What do we? How do you? I think when it comes to default disposition, i.e., when a delegate rule is there and there's no network policies, I'll just leave it as that simple of an explanation. I think we have to be, if we want to toggle that, we have to have an explicit field to toggle it, because I don't think we can be implicit here. I think we need to define what behavior is expected. I don't know what the right answer is there, but that's a problem with network policy.
Think of it as a rule tree. I've set the rule, and if that rule says, oh, this can be overridden, or sort of I can delegate it, but if nothing happens there, you still have a rule to fall back on. And to me, like, you need to set a value. You should not just have something that says you can go either way. The rule should always be a sort of allow or deny in it. So when you set your default disposition here, when you delegate, you need to know what you don't do if someone has doesn't act on the delegation. If
Well, is that a rule defined by the user, or is it an implicit rule that comes with
that
network
comes to me, that comes from the one that says the CSP. He can say this, you have like deny but override, or if you delegate, if no one, think of object orientation. When you use delegation, right? If no one implements the delegation method, you have always a backup, right? Because if you call otherwise, you will get the runtime exception. So you need to have something that you call.
Yeah, so I raised this point last time also. So I feel, this I mentioned last meeting also, the default disposition and strict deny but delegate can be combined into one single use case of like default disposition. So you have your strict deny in default disposition, and if a tenant or a namespace admin decides to make some changes or create a different rule for part of the traffic, they can do at the namespace level, because it is the default disposition. So the deny will, for the rest of the traffic or the superset, will take care only if the delegate does or namespace policy does not allow it. In case the namespace admin does not define any policy, then you will anyway fall back to the default disposition. Like in this case, if I just define.
So here's the other thing, right? The default of a namespace is defined by two ways, right? If you have any policy matching a pod, it automatically goes into network policy, right? And otherwise, if you have no policy matching a pod at all, then it's default allow. So I think it is reasonable to have this default logic be separate from the main CNP, either have a separate CRD, which I think Abhishek and Yang were initially calling DNP, or it could be part of NetPol v2, or it could be an extension to NetPol v1 itself, right? A new, so that's why it is not essential to have that in the CNP CRD.
So Sanjeev, I think I'm not actually questioning where it should go, but what I'm saying is the use case which is described in 4A can be solved by DNP.
Let me try to sort of like comprehend this, right? So essentially what we're trying to, why we separated into those two use cases is because we saw there were basically, there can be two cases. And one is that, you know, a cluster domain may poke a hole like in the strict denies, and the cluster domain would actually don't care if what the namespace owner actually what he does, whether he put a Kubernetes namespace policy, network policy to actually regulate those traffic, or if the namespace owner just doesn't act at all, like the cluster admin wouldn't care by that point. Or there's another use case where the cluster admin wants to delegate this traffic to the namespace or tenant owner, but in case the tenant owner actually doesn't act, they want a default disposition. Now, those are the two different, really subtle different use cases that we had in mind. So our people agree that maybe one is not usually the case, that we should only consider two, or the other way around.
So Yang, are you saying that let's hypothetically think that we have a default policy which is evaluated after the namespace policy, right? Okay. Are you saying that the use case which is of strict deny but delegate cannot be achieved? So my understanding, and I may be wrong, but my understanding was that if we create a default policy at the CNP level, right? Right. Which takes effect only after the namespace policies are evaluated, right? Then that will solve the use cases of strict deny and delegate, and also will solve the case of default disposition.
Well, the problem is that when you have, you know, a default like a deny all, this higher priority deny all sort of will capture everything, and you know it won't get into the you know, the default rules after the Kubernetes namespace network policy, and the default deny all will capture that and drop the packet already.
No, you're saying default deny all at which level?
At the higher CNP level.
No, that's why I'm saying the default should go in the default disposition, right? Which is evaluated later. Giving a chance to the namespace admin to create exceptions on it.
Yeah, I think what Satish is saying is that an empower policy can also function as a default for the namespace.
Yeah, so the first empower, which was actually allowing a subset from a bigger deny, that has to be front. But yeah, actually exactly the mirror image of that is when you have a broader deny, but you want to give a chance to namespace admin to poke some holes in that, that can be evaluated later. So that's why I was thinking that 4A and 5 can be combined. I mean, whatever we come up with, right? The use cases can be combined into single implementation.
But I think my confusion was still at, how if you have, this rule, which is after the Kubernetes network policy evaluation priority, then how would you actually poke these holes for the default deny? Sorry, not the default deny, but the strict denies around the tenant boundaries.
No. So I'm not actually questioning the use case one, which is strict deny. I'm talking about strict deny but delegate, because you are actually delegating, right? So if you don't want to delegate something, you can always put it in under use case one. But if you want to create something where you want to take an action at a broader level, but you want to give a chance to the namespace admin, then you can put it in the lower level, right? Because if everything you put on the one, then it becomes like use case one, right?
Right. I think I understand your point now. The problem being, if we have a strict deny that's depicted as something like this, right? If we wanted to have a default disposition to be in the end eventually actually evaluated, somehow we do need to skip this strict deny, for those default disposition rule items, right? Does that make sense to you?
I didn't get it. So I'm trying to still understand the use case difference between 1 and 4A, right? 1 and 4A means, for example, let's say I'm saying that everybody can talk, and they say nobody should talk to you. No, nobody should talk UDP, for example. Just take a hypothetical example, right?
Okay.
And that, but I know some of the namespace admins want to have that. Then if I put it, if I put that rule in the 5th use case, right? I create a default policy which just says nobody, irrespective of which namespace they belong to, cannot talk UDP. But if some namespace for a particular pod or for some pods, if they want to create an exception, they can create it in KNP.
Oh, right. That makes sense. But our problem is that what if somebody, what if the cluster admin comes in and he wants to isolate every namespace, strictly non-overridably isolate every namespace? Then what he or she would do is write a policy that actually, isolate those namespaces. Now, with that policy already in place, then you sort of like needed either modify that policy, or you needed some sort of like exceptions to, those hard boundaries to allow at least, those traffic to be not evaluated by those strict denies, and it can fall to the default disposition rules.
But if there is such use case, will that not be solved by use case 2? Sorry, use case 3.
No, because use case 3 will be strong allows, right?
Yes, that's what
So
we
it
want.
would
Right?
it'll never make it to any default disposition rules at that point. Like the allow will always allow it at the tenant level, right? The main thing is, like, if you don't have 4, you can never get to 5, right? So
yes, I think that's what I'm saying.
Because there's no way to poke holes in the strict deny. 3 is poking holes that you cannot close with 5 in the strict deny. 4 is poking holes that you can close with 5, right? It's 2 different use cases.
Okay,
Yeah.
maybe if you can take an example, I mean, it is
So
it's
I
okay.
think I don't think we cannot close the holes of 3. Okay, you can have a strict deny but allow on the receiver, but you can block the sender. So remember, these allows and denies are at 2 places, the source and the destination. So if number 3 says it's a policy at the receiver which says strictly deny, but allow these exceptions, doesn't mean that that exception has to go through, because you can enforce this policy at the receiver, but the sender, you can still control which senders are allowed to send. So that's actually another thing that has been slightly missing from our discussions, or at least in these diagrams, which is that you have 2 points to enforce a policy, and you can have a receiver which opens a wider hole, but the senders can be limited.
Right. I agree on that point. But basically, on this picture, you're essentially saying that, if we have these policies on the tenant namespaces, then if the cluster network policy admin comes in and sort of like say, hey, I'm applying a policy on the kube system, kube DNS pods, and I'm telling the DNS pods, you can't talk to any of the tenant namespaces. I guess that's something, the cluster admin needs to, have better knowledge on, or at least not apply those kind of policies, because those are actually the policies that contradicts with each other, right? So, we are at least expecting the cluster admins to not apply those kind of policies to make it doesn't work on the other side. Does that make sense?
Yeah, and I think there are some assumptions here on the exact operational model of this multi-tenancy. I think let's keep going. If you have time, I can share a few updates that I've got as well, but go ahead and wrap up.
Okay, cool. I actually wanted to sort of still answer Nadim's question if possible. So you were suggesting some sort of like examples you had in there?
Yeah, so I was trying to understand, like, what is the exception which we can achieve in 4, which is not possible if we just put a default. I mean, whatever is calling strict deny but delegate it, right? I mean, we're calling it a strict deny but delegate, right? Which means we are. So I now understand the use case, but I'm just not sure that it is kind of becoming a language within the policy itself, right? Typically, that policy administrators are accustomed to creating superset, subset kind of rules, right? So I'm just trying to understand the use case of 4, like the very small part of 4, which is like creating a strict deny. So I now understand why you're calling it a strict deny, not as a weak deny or default deny.
Yeah, I think this is that's why what we sort of this kind of like points are sort of like confusing to read. So that's why we pull out this diagram. And so essentially, what I would say, what the difference between 4 and 5 is that, what we depicted, as I said, depicted in the yellow lines here, right? So we all agree. Do we at least all agree that, this yellow lines will be the exceptions to the strong deny? Otherwise, there's no delegation or whatnot happening. It would just be denied by the strict non-overridable denies, right? So at least we need to have a way to sort of like poke holes in the strict denies. Does that make sense?
Yeah, it does. It's just that I was thinking that do we need to go to like a strict deny with holes, or rather than we can just have a weak deny? That will be a simpler to understand policy model, right?
Okay, so essentially you're saying that for the policy, you need to write this way. Essentially, from here to here, it's a strong deny, but for this guy, it's a weak deny.
Yes.
Okay. So now the tricky part is what we mentioned for a really, really long time now, is that how do you write a rule that says for here to here, this is a strong deny? because usually what makes sense to people is that we will have something stack on top of it and says this is the exception we made to the entire thing, right? So if we actually have a good mechanism to do to specify this, then we probably don't even have the delegate and all those problems, because we can just specify the policy that we want exactly and let everything else fall through. So this is a problem that we are facing. But yes, I agree. Essentially the use cases can be depicted that way if we can find a really good implementation that's non-ambiguous, and we can have a default deny actually overriding the strict deny. But that has been really challenging to come up with, I guess.
Okay.
So yeah, I guess
Nadim,
this is another way to look at it.
And Nadim, can you throw some of those opinions on slide 3 in the comments, possibly? And we can move forward from there, and maybe let Yang just try to run through some of these samples so we can see what those YAMLs would look like.
Sure, I'll do that.
Is that all right? Cool.
Yes.
Yeah, so if there are any other questions on this traffic diagrams, also please share it on the as a comments on the slide. Let me post this as a post list link in the chat. All right, cool. So if we sort of like can at least understand those use cases, I guess I think Sanjeev mentioned he also have something to updates to share. So I'll stop there and see if we can get to maybe the example YAMLs that we prepared, all the all-in-one YAMLs and everything we prepared for those use cases in the next meeting. Does that sound fair?
Either way is fine with me, because you guys had asked me to work on some YAMLs. So I've got some. Obviously, we can do more. So
okay, cool. All right. Then I'll stop share for now.
Okay.
I'll make you a co-host. Okay. Should be good.
Oopsies. Okay, so I'll just try to add some notes on a priority-based solution to match the model that Yang was describing. It just to give a little bit more specific thoughts into the picture. Okay, and sorry, so this picture right here. Another point is that yeah, okay, I actually use the picture that we had in the repo, but this is very similar to Yang's picture. Okay, so some thoughts just think about when it comes to priority-based network policies. Firstly, there are two aspects of ordering. Okay, one is how do you order different CNPs vis-a-vis each other, and then what is the ordering of rules within a CNP. So ordering is not just one thing. There are two things. You have to order CNPs in priority, and you have to order the rules within a CNP, and you have to have a plan for both. Right. So when you have to handle multiple CNPs, it helps to have a priority number associated with the CNP, so that you know that CNP1 takes precedence over CNP2. If there is no priority number, and they happen to have overlapping matching criteria and conflicting action types, which is what we would have, it is not clear unless you decide to aggregate across the CNPs. So if otherwise, so that's my point here. Like, number one, having a priority allows you to resolve the ordering at least across CNPs, and possibly even within a CNP. So you can have any number of rules and you know clearly which one takes priority over the other. If you don't have it, if you do aggregation, then a rule in CNPD may override another rule in CNPA, even though there is no explicit indication that CNPA takes precedence over CNPD. And this might be confusing to some admins. So the next point is about network admin familiarity, right? Admins are familiar with priority-based ordering. That's because a lot of equipment and clouds have it. Second, admins are not familiar with overloading the action type into the priority, right? If we have an implicit rule that deny is always higher priority than allow, or empower is always priority than deny, that typically does not have precedence. So it's not something that they're familiar with. Of course, that doesn't stop us from introducing it, but it's just a point to know that that's not something that they're familiar with. And finally, keywords like empower are new keywords. So there will be some ambiguity, right? So if you want to keep in mind familiarity and ease of use, these are points to consider, right? So the points are: number one, admins already use priority-based ordering. Number two, they typically do not overload the action type with the priority, right? It's not that deny is always higher priority than allow and things like that. If we make a rule that requires that would be unfamiliar to network admins. And secondly, if we introduce new keywords, that would also be somewhat unfamiliar to network admins. That doesn't stop us from doing it. It's just something to keep in mind. The other thing is that I'm not looking at this as solution A versus solution B, right? I actually think that these are not even orthogonal, not even opposing solutions. So having a priority number is orthogonal to having additional actions like empower. And we could even choose to have both. So we could even have priority numbering as well as the empower keyword, should we think that that's appropriate. So I don't want to position this as priority numbering versus multiple actions. These are slightly different things. We could even have both. Okay. The other point is we're introducing the CNP because we want customers to migrate from current vendor CNIs, right? And virtually all the current vendor CNIs are supporting priority ordering. Okay. And none of them have a keyword sort of like empower. Again, that doesn't mean we don't do it, but it's all about familiarity and what is the current model. So if we switch to a non-priority based model, go ahead.
So when you say priority order, when you do the CNP versus the standard, right? You have a priority order in there between the CNP policies and the normal network policies, right? Do we need more than that? In that case, okay, we need to specify how it works. If we think it's enough, then you already have it based on that. You already have sort of a that CNP. The algorithms, how you apply the policies based on type, sets the ordering. It's implicit based on the proposal you're coming with, right?
I would guess Sanjeev's this point is that if we don't have those kind of like priority orderings, then the CNP evaluation will be an aggregation of the CNP.
That's what it is. So what you really want, and I'm going to come back and talk about this in a couple of weeks. What you really want is for someone to separate the policies, how you define, from the algorithm that applies to it. I think implicit ordering is way better because it's understandable and sort of you set it. And if you need a new policy type, well, then we should add a new policy type, and then you can change the ordering to just have a flat sort of policy space, and then try to set up some ordering system that you order within that space. I think it's going to be overly complicated. I think sort of the whole idea with CNPs that and other policy types that you get an implicit ordering by defining how these things relate to each other. To say that there is no such thing, then should then a normal user be able to push a network policy in ahead of the network of the CNPs? It becomes really weird. So
yeah, okay. So the goal here is just,
I think the goal should be that you should be able to have a policy system with ordering, but without having to specify priorities based within sort of each plane in the algorithm that's used to apply to the policies. That I think should be the best. Can it be avoided? I don't know.
Yeah. So the point here is just so that we are making sure we understand the pros and cons of all approaches, and it's not that these are all A versus B. You can have A plus B, right? So that's what we are saying here, that these are facts to keep in mind, right? Number one, there are two aspects of ordering. It goes without saying that we are talking about cluster admin policies always higher priority than network policies, right? So that is understood. That is true for all these proposals. But even within that, how do you prioritize within the different rules of a cluster network policy if they can be overlapping? One is you have to have a agreed design for ordering across CNPs, and second, an agreed design for ordering within multiple rules of a single CNP. Just making sure we're just thinking through this, right? And so here are the issues when you have to handle multiple CNPs. Here's the issues related to network admin familiarity. And again, reiterating that you can actually have both. This is not A versus B. It could be A or B or A plus B. And then there is the adoption issue for the current vendor CNIs. So, right, if you look at what the current vendor CNI is doing, almost all of them support priority ordering. So if we switch to a non-priority based model only, it makes it, they have to redesign their current deployments, and we may or may not, some migrations may make it difficult.
So this is maybe proactive. Does any of the CNI providers today care at all about what's in Kubernetes network policy? They've done their own, right? I mean, I don't know where everyone works, but do we see a lot of the CNI providers being really active in this, or are they just going to go with their own stuff anyway?
So we're talking about the cluster scoped policy equivalent that the CNIs have. So every vendor, and especially Calico, Cilium, and maybe a few others, maybe Antri as well, they all have a separate notion of cluster scope policy from regular network policy.
Yeah.
So this statement applies to their version of cluster net. So if our goal with this effort is to have an upstream cluster network policy that will allow people to move away from the vendor CNPs.
So if I would say that, I think the big problem here is that everyone is directly depending on the network policies, and in the end, we're going to have to change that. We need another layer in between. But
so they have their own version of CNPs, right? So if our CNP cannot provide functionality that their vendor customers will be incentivized to reach,
you want to have something that's at least at rich. That's what you're saying.
At least most of the common use cases that the vendors are solving, we should be able to solve. Otherwise, this will limit the adoption of the CNP. And people will just stick with the vendor.
What I'm saying is the people that already implemented their CNPs, do you think they will really implement a standard way as well, or will they just keep theirs? That's my, is that what makes them unique and different?
No, our at least the hope for pushing the CNP at least is to have all the major CNI vendors to implement this cluster network policy as well. Maybe in definitely, you know, in addition to what they already implement as a cluster scope policy, because this will be a standardized way across Kubernetes distributions, so that, you know, when maybe we have a sample CNP which says that we can use the CNP to do blah blah blah. For example, you can use the CNP to always allow quick DNS. Then you can apply this to any vendor of your choosing and achieve the same results.
And what you're saying in the bullet 3 here is like, yes, with empower and delegate, you should be able to do this in the same policy, but people might not be used to do that, and it's not always good to open up a policy all the time. But if all you want to be able to do, right, is to shoot in a delegate or an empower, or I mean, we should be able to specify the priority orders in that case, that if you want to be able to shoot in an empower rule 4 on top of a call it the default wider CNP policy, that's just one level you need, right? How many levels you need? Can you add that into the algorithm and say that, yes, you should be able to add delegates on top of it, or empower, so that overrides the default one? That to me is 2 levels. You can have a So you first check if something is empowered, then you check if something is delegated, and then you check the default rule.
So we have about 2 minutes left. So if Sanjeev, you want to just
Yeah, let me just show one example YAML. So basically, this were the points to keep in mind, right? And
Yeah.
there's migration, flexibility, all of this network admin familiarity. So here's one example YAML. I was hoping to have more, but I don't think we have time to do more anyway. So let's just look at this one YAML. Right. So here is this one YAML potentially, which is doing a multi-tenancy case, and the requirements are, oops, sorry.
And this is the default rule, right?
Must block
Yeah.
inter-tenant ingress and egress, must allow monitoring traffic coming in from the Prometheus namespace, must allow egress to kubedns, and defer all the intra-tenant traffic to the namespace. So here the spec explicitly gives a priority order number to this policy, right? So you know that this is order 10. If I have any other policy which has an order 20, no matter what its overlap, this priority will take precedence, right? So your most important policies would have higher orders. And if you don't care about the orders, if your rules can be listed, multiple rules in the same policy, so be it. So here, there are 2 ingress rules in the same policy. Now here, the ordering within the policy is based on the fact that you have 2 rules. The first one takes priority over the second one, right? So here, so this is saying I have a CNP of order 10, and it is applied to all tenants that happen to belong to what I have called class A tenants, right? So this is matching labels. I have enforced a label called tenant class, and all class A tenants need to have this behavior, right? So what this behavior is, that there are 2 ingress rules, which says you must allow traffic to come in from the Prometheus service, because that's what the cluster admin is using to monitor everybody. So he must allow that traffic to come in, right? And you must deny traffic that is coming from a tenant that is not yourself. Okay, so these are the 2 ingress rules ordered according to the fact that the first rule is implicitly higher priority than the second rule, right? So the first rule is defining the exception, which is must allow, and the second rule is defining the must deny. On the egress direction, go ahead, was there a question?
Yeah, sorry, I had a question. So if I'm understanding this correctly, you were saying that, because we have 2 ingress rules in the 2 froms, and you want this to be an implicit priority, meaning the first from and the first action will be a higher priority than the second from and the second action, right?
Mm-hmm.
So I know this is, very unlikely, but that means that if we have another CMP of all other 10 also,
I was going to ask the same thing. Yeah.
And the first ingress rule of that policy will have a higher order than the second ingress rule in this policy, and that's what's implied here, right?
If you don't have the order field, then they're all overlapping orders. Then the same issue applies. Okay.
Right. Exactly.
So having the order actually allows you to separate. Otherwise, every one of your CNPs are clashing with each other.
No, I don't want to defer this conversation because we're over time. So yeah, maybe we can take this discussion to the next meeting.
Yeah, let's pick up here next week. I think the one comment I did have though is we can narrow down this order problem. We literally could make ingress section only allow 1 policy to have 1 rule. Like we can make this however we want. Like this is a complicated problem, and I think it applies to both scenarios. And I think we should talk about it more. But we are at 5:03, so.
Yeah.
Okay. So yeah.
Let's continue on this, but also sort of the specific case when you have same order and different results, right? That's something we need to have resolved. I mean, to have a resolution for it, to say what's supposed to happen.
Yeah, everything needs, that's my most important outcome here, right? There's too much implicitness in network policy. Cluster network policy cannot be implicit. It needs to be explicit, right? For understanding, for the complexity, everything. So that's kind of where I'm at.
Yeah. So, okay, we can continue next time.
Great. Awesome. Thanks both of you for putting together some presentations. They're really awesome. And please share those links with me or put them in the agenda directly so that people can go back and comment over the next week. And we'll just continue this discussion.
Take care, guys.
Great. Thank you, everyone.
Thank you very
Have a
much.
good week.
Thanks,
Bye.
everyone.
Bye-bye.